Hello everyone, welcome to Fantastic Datasets and Where to Find Them. In this video, we are going to explore a severe worldwide problem, skin cancer, and how a unique dataset might have just brought us closer to a solution. Throughout this video, Blue here is going to accompany us and lead us all along the way. So let's start. Skin cancer is a silent epidemic. According to some estimates, every year over 5 million cases are diagnosed globally, with melanoma, BCC, and SCC being the most common types. Melanoma alone accounts for a significant number of cancer deaths. But it doesn't have to be this way. The key to surviving skin cancer is early detection. According to the Skin Cancer Foundation, the estimated 5-year survival rate for patients whose melanoma is detected early is over 99%. The survival rate falls to 74% when the disease reaches the lymph nodes and 35% when the disease metastasizes to distant organs. Here, technology offers a potential solution. Imagine being able to capture an image of a mole with your smartphone, have it analyzed by AI, and receive an immediate recommendation. And this is where ISIC comes in the picture, who are working to make things just like this a reality through their efforts. One of ISIC's most notable initiatives is its annual Grand Challenges. These international competitions challenge researchers to develop cutting edge AI models capable of analyzing skin lesions with exceptional accuracy, just to name one. The grand challenges don't just test AI models, they also push the boundaries of what datasets can truly achieve. And each of these challenges provides contestants with access to expertly curated datasets, ensuring that their work is grounded in real world conditions. And in this video, we specifically talk about the 2024 Grand Challenge, which represents a major milestone. Now let's find out how. The Slice-3D dataset is at the center of the 2024 Grand Challenge. It's a collection of over 400,000 skin lesion images sourced from 7 leading dermatologic centers across 3 continents, making it one of the most comprehensive skin imaging datasets ever created. This dataset was created to address a critical gap in the field of skin cancer detection: the lack of accessibility and practical tools that can function in real world, non specialist environments. Well, traditional datasets rely heavily on high resolution dermoscopic images, captured using these very expensive, specialized equipment typically found in dermatology clinics. Slice-3D breaks the barrier by focusing on images that simulate smartphone quality photos, and these lower resolution images mimic the conditions under which patients and primary care providers or even telemedicine platforms might capture lesions. Now let's see how this dataset was acquired in the first place and in what format. So this dataset was acquired using 3D total body photography with the Vectra WB360 system, which employs 92 DSLR cameras and xenon flashes to capture high resolution images of a patient's entire skin surface in just one session. Lesions were cropped into 15 by 15 tiles using AI driven tools, ensuring optimal framing and consistency across the dataset. And then each of them de identified image is saved as a JPEG file averaging 133 by 133 pixels, simulating smartphone quality resolution. Now let's move on to the features of this dataset. The Slice-3D dataset is designed with both scientific rigor and real world use case in mind, making it a groundbreaking resource for dermatology research. It focuses on smartphone quality photos, bridging the gap between clinical grade imaging and practical real world applications like telemedicine. And not only that, but as said before, the data set is standardized with all images cropped to a 15 by 15 field of view, averaging 133 pixels by 133 pixels, ensuring consistency while reflecting real world variability. Besides, it is accompanied by rich metadata including lesion size, lighting type, anatomical location, and patient demographics, to name a few, ensuring it supports detailed analysis and machine learning integration. While this dataset is a groundbreaking resource, it does face some challenges. One major limitation is the lack of skin tone data, which can impact its applicability to diverse populations. Also, the variability in image quality, such as lighting and resolution, reflects real world condition but makes AI training much more complex. Additionally, privacy driven de identification removes contextual details like surrounding skin, which could be useful for analysis. And finally, the reliance on weak labels introduces some uncertainty compared to pathology verified labels. Any discussion of a dataset is incomplete until we have spoken about the FAIR principles. So let's talk about it. Spoiler alert, the Slice-3D dataset fully adheres to the FAIR principles. It's hosted on the ISIC archive with permanent DOIs, making it easy to locate. The dataset is openly available with clear licensing options, ensuring accessibility for researchers worldwide. Its standardized metadata supports integration with machine learning tools, while rigorous quality assurance guarantees accuracy and long term reusability. Now, to the challenge. The ISIC 2024 Grand Challenge showcased incredible innovation powered by the Slice-3D dataset, with over 3,400 participants submitting nearly 80,000 solutions and about $80,000 in prize money. This competition tackled the task of distinguishing between malignant and benign lesions. Models were evaluated on metrics like partial area under the ROC curve, ensuring high sensitivity for detecting high risk lesions, and top 15 retrieval sensitivity, which ranked the most concerning lesions. To conclude this video, let's wrap up with future works. The results of this ISIC 2024 challenge opens doors to exciting future possibilities in AI driven dermatology. Building on the success of Slice-3D, researchers could address, let's say, current limitations by incorporating skin tone data for more inclusive AI models and analyzing patient level context, such as lesion patterns over time. Also, exploring multimodal data integration, so combining Slice-3D with dermoscopic or histopathological images, could enhance diagnostic accuracy. Besides, real time integration into telemedicine platforms and smartphone apps promises immediate feedback for patients. And expanding datasets to include longitudinal imaging would also allow tracking lesion progression for better risk assessment, paving the way for globally impactful and accessible AI tools in dermatology. And with that, this video comes to an end. Blue and I are very, very grateful to have you around until the very end. So, until next time.